We're surrounded by technology that feels like magic. But what happens when that magic has a few tricks that even its own creators can't figure out? In this explainer, we're diving deep into modern tech's biggest unsolved mysteries. No, really, just think about that for a second. That phone you're probably holding, the AI that's reshaping our world, the entire digital universe we live in, what if there are parts of it that are running on principles we just don't fully understand? Well, that's exactly what we're doing today. We're opening the case files on 5 massive puzzles that are stumping some of the smartest people on the planet. So let's get into it. Our first case file. Man, this one takes us straight into the weird, mind-bending world of quantum computing. This isn't science fiction anymore. It's the absolute frontier of what's possible, but it's haunted by this huge, almost ghostly problem. Okay, so what in the world is quantum decoherence? Well, a quantum computer's power comes from these things called qubits, which can be both a 1 and a 0 at the same time. But that special quantumness is super, super fragile. The tiniest thing, a little vibration, a slight change in temperature, can make it collapse into just a boring old 1 or a 0. That collapse is called decoherence. It's kind of like trying to build a really elaborate sandcastle while the tide is coming in. And that's the real heart of the mystery. It's not just that decoherence happens. It's that we can't figure out exactly when or why it's going to happen. It's just too unpredictable. The tools we have now to fix these errors, they just can't keep up. So until somebody cracks this, that dream of a world-changing quantum computer, well, it stays a dream. And you have to understand, solving this isn't just some academic puzzle. It is literally the key that unlocks the next era of computing. We're talking about breakthroughs in medicine, in material science, you name it. The stakes are absolutely massive. All right, mystery number 2. This one is happening right now, inside the most powerful AIs we've ever built. The weird part is, we've successfully created these incredible digital minds that we don't entirely understand. So think of it this way. When a human expert makes a big decision, they can usually explain their thought process, right? Step by step. But with a lot of these deep learning AIs, they give you an answer, and it's often an incredibly good answer, but how they got there is a total mystery. It's locked inside what everyone calls the black box. And this leads to a huge, really fundamental question. If an AI tells a doctor a patient has cancer, or denies someone a home loan, or is driving a car, how can we put our full trust in that decision if it can't tell us why? This is a massive real-world problem. There's an entire field now called explainable AI that's trying to build tools to peek inside that box and translate what the AI is thinking into something we can understand. But honestly, right now, we're just getting small glimpses. Truly understanding the minds we've built is still one of the toughest challenges out there. Okay, for our third mystery, we're going to zoom way out and look at the very thing our entire civilization is built on now, data. And you might be shocked to learn how much of it is unknown and how fragile all of it is. Just get a load of this. An estimated staggering 90% of all the data we create is what's called dark data. This is all the stuff our systems collect but never use. Old server logs, security footage, sensor readouts, it just gets packed away. It's this enormous digital ocean that might hold incredible secrets, and we've barely dipped a toe in it. But here's the real kicker. Even that tiny 10% of data that we actually use, our photos, our work, our history, the stuff we think is safe forever, it's basically living on borrowed time. It's a phenomenon called data degradation, or bit rot. Seriously, over time, the little ones and zeros that make up our digital files can just fade. They corrupt. Unlike, say, ancient carvings in stone, our digital legacy is incredibly fragile. So the mystery is twofold. What's hiding in all that dark data, and how do we stop the data we care about from just disappearing? All right, let's get to our fourth enigma. This one sounds like it's pulled straight from a comic book. The quest to create technology that can actually heal itself. I mean, think about it. You get a paper cut, and your body just knows what to do. It senses the damage, sends the right stuff to fix it, and seals the wound. The grand challenge for scientists is to build that exact same intelligence into things like plastic or metal or the circuits in your phone. But it turns out that's incredibly difficult. It's really a 3-part problem. First, the material has to realize it's broken. Then, it has to get the healing stuff to the right spot. And finally, it has to start the repair process without messing anything else up. Nailing all three of those steps is the holy grail for this entire field. And this quote just says it all. Imagine it. A phone screen that fixes its own cracks. A bridge that repairs tiny fractures before they become a problem. It would completely change what it means to build something to last. It's a total game changer. And that brings us to our final and maybe most legendary mystery. This is a scientific puzzle that for decades has been a source of incredible hope and just as much controversy. We're talking about cold fusion. So the promise is almost too good to be true, creating nearly limitless, clean energy from a simple reaction at room temperature. But the history of cold fusion is really a story of frustration. A few experiments have hinted that it might be possible, but for decades, nobody has been able to make it happen reliably. So you have this constant battle between deep, deep skepticism and that nagging, tantalizing question, but what if? So let's just quickly recap the incredible puzzles we've just walked through. We have quantum computing being haunted by decoherence. We have advanced AI with its mysterious black box brain. Our own digital legacy, threatened by decay and dark data. The incredible quest for technology that can heal itself. And the ever-elusive dream of cold fusion. Every single one is a monumental challenge with a world-changing prize at the end. And that's really what this is all about. These aren't just technical glitches. They are walls at the absolute edge of what we know. So the real question to leave you with is, which one of these walls do you think is going to fall first? And what on earth will our world look like the morning after it does?